All right, we're going to continue working with radicals in the next unit. And we so far covered the concept of simplifying radical expression with roots and higher indexes, more than just square roots and all that stuff. And now we're going to jump into some more properties of radicals. These are actually extensions of the laws of exponents, but we're going to get into that a little bit later. So we're just going to dive into these 4 examples, jump right in, and then I'll do background knowledge as we need to. So we're going to jump right into the first question, and you can see, well, we just need to simplify that crazy-looking expression. And there's something we might want to know that would help us with this. And it's again, basically an extension of the laws of exponents. And if you remember, a law of exponents is this. If I have a to the n times a to the m, I'm looking at a to the n plus m. So that's, we're going to see later in the chapter how this relates to what's about to occur. So what is about to occur? With this thing, there's a law of radicals. Very similarly, the square root of a times the square root of b is equal to the square root of ab. And that's just a property that we can work with. So it leads us on to number 1. We go to number 1 and we read here, this is the cube root of 9. And remember what the cube root is asking, is what number times itself 3 times gives you 9, right? And so we're thinking, well, what number times itself gives you 9? And there's nothing. There's no rational number, right? So there is none. And then you move on to the cube root of negative 81, and then you're thinking, well, what number times itself 3 times gives us negative 81? And again, there's nothing there as well. So then it's like, darn it, now what, right? So start thinking, now what? We have to be aware of some things. You're going to see in this lesson, it's all about awareness. So we're thinking, now what? Now what can we do? Now we can apply this little rule. And that's what. So we're thinking, now what? That's what. So what this little rule says is that if I have the cube root of 9 times the cube root of 81, that means I can have the cube root of 9 times negative 81. All right? Now, what can we do with that? Can you go ahead and multiply 9 times negative 81? Yeah, you could, right? There's nothing wrong with that. You could totally call it this, the cube root of negative 729. That's fair enough. If that helps you get to what the solution is, then knock yourself out. Or you could visualize it this way. You could visualize it as the cube root of 9 times negative 9 times 9. Right? You could totally visualize it that way. And then you could start thinking, the cube root of 9 times negative 9 times 9, wouldn't that be the answer to, basically the answer to the question? Remember what the question is asking. The cube root asks, what times itself 3 times gives us what's inside, right? And that's the question of the cube root. So we look at this setup, and we know that a positive number times a negative number is a negative number, and the whole thing is negative, but we're going to get back to that in a second. First, let's see if we can get the number sense. So what number times itself 3 times gives us 9 times 81, or 9 times 9 times 9, or negative 729? No matter which way you're thinking of it, you should be coming up with the answer that the number, when you multiply it by itself 3 times, it's 9. Okay, so we should know we're coming up with something to do with 9. But here's where sign sense comes in. We have to be aware of signs. So you might be thinking, well, only one of these is negative, right? So it doesn't matter how many things are negative. If the entire cube root is negative, well, then the answer is negative, right? So you have to think as far as sign sense. So if the entire cube root is negative, then the answer is going to be negative. So it's not just 9. You don't have to worry about, well only the negative 81 is negative, but it doesn't matter because the positive times the negative is negative, or positive times the negative times positive is still negative. Either way, it's still negative 729. So it doesn't matter. The answer is going to have to be negative 9. So we look back at what we've just done, right? We have the cube root of 9, the cube root of negative 81. We can't work with them separately. We have to be aware of this little rule and put that together, and then we can totally work with it, right? And then we can answer the question. So be aware of things so you can work with things, and that's a life lesson. All right. Similarly, now we're going to start looking at number 2, and this is where things get crazy. All right. So we got this crazy-looking thing. It's the 4th root of 64 times x to the 3rd, y to the 6th. This is where stuff gets nuts. All right. So we have the 4th root of a number that does not have a 4th root, right? Son of a gun. And then we have the 4th root of variables that also don't have 4th roots. Well, that's hard. So now we have to get into a neat little concept. First a reminder, trip down memory lane. So concept, memory. If we had the square root of 8, how did we work with the square root of 8? We had to look for perfect square factors and then simplify it, right? So the square root of 8 is actually square root of 4 times 2, or the square root of 4 times the square root of 2, or 2 root 2. Okay, so notice what's happening. We have a number inside a radical, and then you can factor out a perfect square. So you'd have a number outside the radical and still some stuff inside the radical. That may occur, okay? So we have to get into that memory. So let's jump into some concepts with that. Let's say I had something like the square root of x. And you may be thinking, well, what is the square root of x? And the square root of x is the square root of x. There's nothing else we can do with that. The square root of x is done. That is as simplified as we can get it. Okay, simplified. That's as simplified as we can get it. Okay, so then we can look at something like this. Well, what is the square root of then x squared? And the square root of x squared is going to be x. But if you remember from the last lesson, it's not only square root of x. Since we have an even index and an odd exponent, we need the absolute value of x. Okay, so the square root of x squared is actually x. Now, here's where things are going to get crazy. What would happen if we had the square root of, well, x to the 3rd power is what I meant to write. So what if we had the square root of x to the 3rd power? This is where stuff gets nuts. Now, remember what we did with the square root of 8, right? So you totally remember we had to look for perfect square factors. We could do the same thing with this. Okay, so this whole concept now, we're going to do the same thing with this. So if we had the square root of x to the 3rd power, remember the index is 2, right? The index is 2. So we're going to look for factors of x cubed that will work with an index of 2. So we can do just like we did with the square root of 8. We can call this x squared times x, right? Isn't that x to the 3rd power? And this again goes back to awareness. The key element for this lesson is all about awareness, playing heads up ball. So x to the 3rd power is actually x squared times x. Why is that important? Because we're dealing with the square root and we're looking that the index is 2, so we want to find exponents that are also 2, right? You get what I'm saying? And so then what we can do is do just like we did with the square root of 8. And then we'd have, well, the square root of x squared is the absolute value of x, and then the square root of x comes together. So what just happened? So you have to see what's occurring. I can't. There's no one thing that is multiplied by itself that gives it x to the 3rd power, but we can simplify it just like we did with the square root of 8. It's the same thing. All right. So let me do another example. So take this out, right? So if we have an example, let's say I had the square root of I don't know. How about x to the 7th, right? If we had the square root of x to the 7th, we want to make perfect square factors, right? The index is 2. We want to make perfect square factors that we can factor out. And did you know x to the 7th happens to be x to the 6th times x? We are playing heads-up ball on that one, right? So we're playing heads-up ball. So we have the square root of x to the 6th times x, because that enables us, because we are aware, that enables us to set this up. Okay, so we have the square root of x to the 6th times the square root of x. Of course, square root of x to the 6 is x to the 3rd times the square root of x. And since we have an even index but an odd exponent, we do need absolute values. Okay, so that's what would happen there. All right, so far so good? I hope so, because now let's think a little bit more. I'm going to challenge your thinking. Okay, so let's challenge how we think we're thinking. Let's say I had the cubed root then of x to the 4th. How in the world are we going to address that? The cubed root of x to the 4. Now the index is 3. So what do we have to do? We have to look for perfect cube factors of x to the 4th. So this is where stuff is going to get nutso. We have to start thinking now, being aware. The cube root of x to the 4th happens to be the cube root of x to the 3rd times x. Is that not x to the 4th? Totally it is, right? Isn't that cool? And then if that's the case, we can apply the rule that we've been applying. This means this is the cubed root of x to the 3rd times the cubed root of x. I don't want you to get too messed up. So notice what's happening here. I want to draw your attention that the index is still applied, right? So draw attention. The index is still applied. Okay, so make sure you know that when you're splitting it up, the index is still applied. And now we can start thinking, what is the cubed root of x to the 3rd? Of course, that is x. And then this, well, what's the cubed root of x? It's the cubed root of x. All right, so far so good. I hope, so far so good. Now we're going to do one more example of this concept, and we can jump right back into number 2. Okay, so another example of this concept. What if we had, now I'm going to go crazy just because. What if we had the 8th root of x to the, how about 31st power? That is going to mess your day up. Okay, so we're going to take the 8th root of x to the 31st power. So, what's the index? The index is 8. Okay, so we are looking for exponents that are 8 or multiples of 8. And so we have to start thinking, what's the highest multiple of 8 before 31? And this is where stuff gets nuts. So start thinking. The highest multiple of 8 before 31. And hopefully you're coming up with this. X to the 31st power happens to be x to the 24th power times x to the 7th power. I hope you came up with that. I hope you realized that. Because we can't take the 8th root of x to the 7th. The index is 8. The question is, what number times itself 8 times gives us what's inside? This is not, we can't do anything with this. This we can. Okay, so what number times itself 8 times gives us 24? That's going to be 3. So we can, So we can take the 8th root of x to the 24th, and we can take the x root of x to the 7th and see what we can simplify and what we cannot. All right. So what is the 8th root of x to the 24th? This is where we have to think. This is going to get crazy. Okay? So what number times itself 8 times gives us 24? 3, like I said. So the 8th root of x to the 24th is actually x to the 3rd power. And then we have this. We can't do anything with that radical sign, so that stays put. All right, so that is pretty messy. That's how that works, and we're going to see more of that in these examples that I presented to you today. But now we have to remember some stuff from the previous lesson. We had an even index and an odd exponent. We need absolute values out there for x to the 3rd power. Okay, so we have to protect for the principal root. And that's how this concept is going to work. The concept of indexes, and the exponents and how that works. We have to keep that in mind when we're looking at number 2. Okay, so it's all based off of what we should be comfortable with here. Right? So the whole thing is based off of here. So we took this concept and just went crazy. All right, so now back to number 2. Now we have the fourth root, 64, times x to the third power, y to the sixth power. So what we can do, we can exercise the first rule. Remember, the square root of a times b is equal to the square root of a times the square root of b. Okay, so let's go ahead and do that with this. So we'll take the fourth root of 64 times the fourth root of x to the third power times the fourth root of y to the sixth power. Okay, so this is all being multiplied now. Hopefully you remember that. It's all being multiplied now. That's going to come back in a minute. So now we're going to figure, what is the fourth root of 64? What number times itself gives you 64? Is it 2? No, 2 would be 16. Is it 3? No, 3 would be 81. So what are we doing? Okay, so we have to see what we could do with this 64. Are there any fourth powers that go into 64? And remember what I just said. 2 to the fourth power is 16. 3 to the fourth power is 81. So we have to use 2 to the fourth power. So we have to think this now is actually the fourth root of 16 times 4. Okay, so that's what we're looking at there. And then we can work with that first. So now we have the fourth root of 16 times 4, which means we have the fourth root of 16 times the fourth root of 4. And the fourth root of 16 is 2. Okay? So it's good old 2. It's not plus or minus 2, it's good old 2. We don't need the absolute value for that because we already have the principal root. Now, some people might look at this and want to do something with it. You can't. There is no number that when you multiply it by itself 4 times is 4. If you're thinking 1, shame on you. 1 times itself 4 times is 1, not 4. Don't do that. Okay, so don't look at this and think you can do something that you can't. All right, so cut that out. That's as done as we can go with the fourth root of 64. It involves a little bit of thinking. Now on to the next thing. We have the fourth root of x to the third power. Is there any way we can split up x to the third power to get something that could be where we could take the fourth root of it? And no, we can't. This is done as done can be. So that's actually still the fourth root of x to the third. What about y to the sixth power? So we have the fourth root of y to the sixth power. Can we break up y to the sixth power into factors where we have a perfect fourth? Okay, and the answer is of course we can. Y to the sixth power happens to be y to the fourth times y squared. That's totally doable. And then we can do just like we've done before. So that's the fourth root of y to the fourth times the fourth root of y squared. And guess what we can do with the fourth root of y to the fourth? We can call that y. Neat. All right, so now not quite done with that y, because guess what we have? We have an even index, an odd exponent. We do need absolute values there. Okay, so be careful. Even index, odd exponent, absolute values needed. So what do we do with this? What do we do with this now? How do we clean that mess up? So let's make a note. Clean this up. Clean up aisle crazy. And to clean that up, we have to look at this, but then go the other way. What? So to clean it up, we have to remember that, well, the square root of a times the square root of b is equal to the square root of ab. Isn't that neat? So what we can do then is go the other way. All right, so let's take what we have here. We have 2 is not inside the radical, and neither is the absolute value of y. So guess what? We have 2 times the absolute value of y. Inside the radical, we have 4 x to the third power y squared. And that is cleaned up. That is what happens when we simplify this. So we simplify the original expression. This is what we have. Isn't that neat? I think it's neat. You might think it's tricky. All right, and then I think what I'm going to do is stop. I'm going to stop for today. This is plenty of information to wrap your head around, and then I'll continue with another video after this. So we'll finish up number 3 and 4 in a separate video. So we're good with multiplying. Now we're going to see about dividing momentarily. Thank you.